Hey guys, so this video is about electrons and light, which is a pretty interesting topic in my opinion. It explains why this pen is red and this one is cyan. But what actual use is this knowledge? Well, the theory here has applications in all sorts, from the production of coloured materials right the way through to identifying the elements present in distant stars. So with that in mind, let's dive right in. We're all familiar with the Bohr representation of an atom, a nucleus in the middle comprised of protons and neutrons orbited by negatively charged electrons. The orbits in this model just represent energy levels. When an electron gains energy by absorbing a photon, it jumps up to a higher energy level, and when the electron emits that photon, it loses energy and drops back down to a lower energy level. We can represent this as an equation. Here, delta E represents the change in energy of the electron as it moves up or down energy levels. H represents Planck's constant, and V represents the photon's frequency. This clearly shows the frequency of a photon directly relates to the change in an electron's energy level. In other words, a photon with a frequency that corresponds to blue light will cause an electron to move a different number of energy levels than one with a frequency that corresponds to red light. So, when light hits an object, certain photons are absorbed, their energy being used to excite electrons to higher energy levels. This means that the colour those photons represent is hidden. Now only the complementary colour is available to our eye, and so that is the colour we see. For example, if red light is absorbed, then we see cyan. We can represent this in an atomic absorption spectrum. The black bands represent the frequencies of light which are absorbed. Remember, the energy levels in all elements are slightly different, and so the bands for two different elements won't match. This means looking at absorption spectra is a great way to identify elements present in an unknown sample. In fact, this is exactly how we can identify the chemical makeup of distant stars. Well, that's about all we have time for. I hope you've enjoyed this video and learnt something new. Thanks for watching.